folks. So only 3 sessions to go. We have Ana Beatriz with us. Now she comes from Brazil and works for Itaú, and she's going to talk to us about the JVM under the hoods. How are you today, Ana?
I'm fine. I'm really excited. so anxious about this talk, but I'm fine.
Okay, so where in Brazil are you located?
São Paulo.
Okay.
I'm from São Paulo. It's really nice. It's cold here and raining. It's a good day.
Okay, so let's go and see your talk. Good luck.
Yeah. Okay, thanks. Thanks, guys. So I'm going to start it here. And I'm really, really excited of this opportunity to you to introduce my talk. So let me see here. So guys, welcome to my talk, and we are going to talk about JVM or Java Virtual Machine and how everything works under the hood, okay? So I really like this team and I use a lot of my job, so I really like to share about this and share how the things works under the hood about JVM, okay? So this is my Twitter, and this is something about me. My name is Ana, and today I'm working building things with Java, Angular, and all the ecosystem with Java in a big bank from Brazil who calls Itaú Bank. Besides that, I am organizing for some communities like So Java. So Java is the most big community of Java developers and Java users, and I really like to be part of that. It's a great group. And well, I'm part of Makers Code too. Makers Code is the most big community for improve women in technology, so it's very nice. And this is my social medias. And if I can answer some questions here, you can add me on Twitter or LinkedIn. And all the codes that I'm gonna show here is in my GitHub. Okay, so make it free and add me on the social medias and let's be connected. Okay, let's talk about me because not me is necessary. Let's talk about the job PM. So this is some spoilers about what we're gonna talk today. Okay, so folks, here's some topics that we're gonna talk today. I'm gonna show you a lot of what's going on under the hood with JVM, and I am so going to show how you can monitor this without Java Mission Control. You're gonna have a code too, a small demo with garbage collector. So I'm gonna show you about the garbage collector and show you how you can test your garbage collector. So it's a very, very nice, okay? We're gonna talk about the compilation and the difference between static and dynamic compilation. We're gonna talk about memory management, Java and heap memory switches, and how you can do this when in your application, in your Java application. So for finally, we're gonna talk about the news in Java 14. We have a lot of things with it becomes in JVM with Java 14, so it's very, very nice. I hope that you enjoy and share with your friends, okay? So, okay, why learn JVM? So, when I started to study JVM, I asked me a lot. And so, what learn this? What can this add to my career? Because actually, my job is very, very necessary to understand JVM because I'm working a big bank, so we provide we deal with the money of the people, so it's very necessary bring the clean software, a clean content for our clients. So today it's very necessary understand JVM. But when I started in my career, I don't remember thinking, oh my God, I don't know JVM. I need to learn. It's very necessary because we have small things inside JVM that is very hard to understand when you are in the beginning of your career. But I started to study until then, and it's really good. It was really good. I knowing so much things, and I made you us to seek understand how everything works on the Java virtual machine. But okay, let's see a little bit of concept, and we can define it whether JVM is an engine that provides runtime environment to drive Java code applications. Okay, so inside of the JVM, we have a lot of language that runs such as Python, Clojure, Kotlin, Scala, and etc. We have another language through that runs in JVM too. And JVM have the responsibility to turn your code executable in any system operation. Okay, you need to understand the purpose of this in this talk, but a little bit of concept of the JVM is this. Okay, so now that definition is okay, I will show you a very interesting article that I found on the internet where it shows some tips for becoming a better Java programming. And among of these tips, this is learn JVM internals and Java performance studying, and it's here. So I like this topic. So if you know the JVM, well, you can write both robust and high performance Java application, and that's what rockstar Java developers do. I really like this. You can be a rockstar Java developer, and this is very exciting. So I really like this article. I put the link here so you can read this before my talk. So it's very, very nice. Okay. I think super cool because understand the compilers, how code is executed, is very necessary. It's necessary and essential for any level of experience in our code always makes better. Okay. So why learn JVM? Now let's return the question of this slide, okay? Learn JVM is fundamental to understand the core of the things and makes you a better developer because probably you level in Java, you will increase it, okay? Because you have you know so much things profound in the you knowledge of the language. And sure, you will be a better able to solve difficult problems. So this is something that I have in my career. So I know so much things, and I be more able to resolve difficult problems. So I really like, and it's very necessary principle for a Java developer in a beginner career. So this is some topics to why learn JavaVM, okay? So let's talk about architecture. Some people don't like to learn about architecture because it's hard. I know it's hard, but it's very necessary. Understanding the architecture, you can understand how your code works, and this is awesome, okay? So let's see how our code works, okay? So let's go back when the things process we see, because guys, did you know the Java is based in C++? So take this into account. The compilation process is done as this way. So C language uses the compiler and linking process to make your native code works in your machine. So here you will have our C code, and this C code passage for a compiler, and this compiler turns our native code in a machine called all the famous binaries, you know, the binaries code. So before this, the linker makes the responsibility to take all these sources and put on and makes this code work in operation systems like macOS, Linux, Windows, and this stuff. Okay. So, but this process isn't the best one because if I needed to run my code in another operation system, all this process runs again. So something that works fine in the Java with VM is the bytecode. Bytecode comes what? So let's understand this. With the native code wrote in Java is compiled with the Java C or Java compiler, and JIT, the just-in-time. We're gonna talk about these two guys more in this talk, okay, in the future. And this compiler turns in bytecode. So, and this bytecode, the JVM is understand and makes the whole application something that runs in everywhere. Because this Java have this slogan, runs one, run everywhere, because you don't need to run again, okay? So I like to put JVM like a coffee machine, because it's something like this, okay? We have a coffee bean, and we put this coffee bean in our machine, coffee machine, and this coffee bean turns a liquid coffee that we can drink. So JVM is basically basically this, okay? I have here a lot of slides to explain a coffee machine, so it's very nice, okay? And I really like Java, okay, guys. I have a tattoo of this. Really nice. I really like all the ecosystems and all the things that we can learn with Java, okay? I'm not a big fan. I need to confess. Okay, so consider this, how JVM stays within all the Java ecosystem. Okay, when you download the JDK or the Java Development Kit, we have all of this with us. We have the JEE or Java Runtime Environment. So Java JEE has the entire development area, including in JVM, basic libraries to use in Java applications, and the execution engine. And out of it, the development tools to make your code better and improve all day. So this is a simple example that we have when you install the JDK, download JDK, okay? But okay, I show you everything that makes you perform in Java, okay, JVM and these things. But many people asked me, why Java is still slow, okay? If compiling process is awesome, why Java is slow, okay? Guys, have a lot of reasons about the Java is still slow. And all these reasons is because the performance inside of them. Because we have a big architecture without Java. So the two main reasons that I put here is dynamic linking and runtime interpreter. What is? Dynamic linking, unlike in the C language, linking is done at runtime. And every time the program is run in Java. A runtime interpreter, because the conversion of bytecode into native code is done at runtime. In Java, it further slows down the speed, okay? And sometimes Java is slow because Java is a compiled and an interpreted language, okay? So it's not a bad thing, okay? We need a robust language to build our applications sometimes. And Java comes a lot of ecosystems. And the latest version of Java has addressed the performance and bottlenecks to the great extent. So Java 14 becomes a lot of things of that. So it's very nice to study of this, okay? So, okay, all of that to make you understand this. I explained all these things to make you understand this. This is a simple architecture about all the JVM. So the things works like that. First, we have the class loader. The class loader is a subsystem used for loading class files. So it performs three major functions like loading, linking, and initialization, okay? And the second step is the method area. Method area stores classic structures like metadata, the constant runtime pool, and the code for methods. So the method area, we're gonna talk about this after, but the method area stays on permanent generation, is a space of memory inside JVM. And the third step is the heap. In the heap stays all the objects They related instance variables and arrays are stored in the heap. This memory is common and shared across multiple threads. The fourth step is the JVM language stacks, and the language stacks store local variables and it's a partial results. We have the persist registers. In the persist registers, it stores the address of the Java virtual machine instruction, which is correctly executing, okay? For finally, the JVM memory, we have the native method stacks. So here, the native method stacks hold the instruction of native codes and depends on the native library, okay? It is written in another language instead in Java. So all this process, we have the execution engine. Execution engine, it is a type of software used to test hardware, software, or completed systems that we use it, okay? For 18 steps, we have the native method interface. Native method interface is a programming framework to allow Java code to run in a JVM to call by libraries and native applications. So it's a framework to call native applications. For finally, all this process, we have the native method libraries. Native method libraries is the commands with C and C++ that we need to do for work in execution engine. So here in the middle, we have a framework to do this native methods libraries works. And for finally, we have our execution engine to receive and comes all of this for our JVM memory. So I hope you understand this. I know it's a little bit difficult, but it's a big ecosystem that we have inside our JVM. And in order, this is how a software programming it is executed. We have a photo first, an editor, and this editor is to type your programming. So you can use the IntelliJ IDEA, Eclipse, and this is DS. We have for the second step a compiler to convert your high language program into a native machine code. The third step is the linker to combine different program files referenced in your main program together. The loader to load the files from your second storage, like a hard disk, for example. And you have execution like a execution engine to execution this in your processor, okay? So this is very nice. This is how all of this works without a JVM, for example, if you want to run this by yourself. So, okay, nice. Let's see there now how JVM stores the objects and methods, because now we have the whole background and we can understand the why of the things within JVM. And yes, I like to put GIFs. I really like because it's more nice to understand the things, okay? And let's see about the compilers, okay? A compiler is nothing more than a translator. You can put it in a knowledge too, okay? Compiler is a translator of our code to a machine code. Okay, what a compiler do? A compiler is a fusion. What it means? What do we got? What is a fusion? A compiler takes a programming language as an input and produces an executable language as an output. So this is a work of compiler. This just takes our code and turns this code in a binary and something that a machine is gonna understand. Okay, it's like a fusion. Analogy too. I like analogies for makes your understand the things more funny. Okay, a compiler that many of us know is Java C or Java compiler, which included in all standard Java DK, Java development kits. And we have some compilers inside JVM, such as JIT or just-in-time, hotspot, and all this stuff. And the mean of all of these compilers is turns our code translation into a bytecode and something that our JVM is gonna understand, okay? So the executable language for JVM is bytecode. So the purpose at the Java C is make this job. So the bytecode can be read by standard CPUs and need to be translated into an instruction language that the execution platform can understand. So this is the deal of the compilers make this job, okay? And in addition to Java C, there is also JIT or just in time, okay, which is one of the compilers responsible for bringing performance to the JVM. And when the JVM first starts up, thousands and thousands of methods are called. So JIT is a compiler uh, to provide performance inside JVM and makes the one that makes JVM makes faster and so good for our applications. And the data is obtained directly from the actual execution of the program. So this compilation just require processor time and memory usage. Okay, we're gonna see more about this in the next slide. Okay. So compiling all of these methods can significantly affect its startup time. So even if the program eventually archived, very good peak performance too, okay? So the just-in-time working something like this, okay? So we have our source in wrote in .java, so the code that we wrote, and this code passed for the compiler like Javac, and this compiler turns our code writing in .java in our code wrote in .class. So .class is the source that is in bytecode, is the bytecode. So past this, we have the JIT compiler in action. So when JIT compiler works in action, then turns our code, all of this bytecode in a native code that is the thing that the JVM is gonna understand. Okay. So the JIT works in a runtime area because the JIT is really fast and is really good because work is a runtime area. So this is how makes JIT so much fast and it's really nice. So yes, now you can see it that we have the Javac and we have the JIT compiler. And we need we have different compilers for different applications, okay? But the most important thing is that you need to work with your VM, okay? Okay, here is some examples of different compilers inside of JIT. So the JIT compilers come in two flavors, and the choice of which compiler to use in often is the only compiler tone that needs to be made when running an application. In fact, knowing which compiler you want to choose is something that must be considering even before Java is installed, okay? Since different Java binaries contain different compilers. So what is the means? You need to choose what compiler you want to do before you install the Java, all the JDK, okay? You need to have this in your mind before this. You have two types of compilers inside JIT2, the client-side compilers and the server-side compilers. The client-side compilers, we can call them for C1, okay? We're gonna see the client side like a C1, and it is a compiler activated through a JVM initialization like a client, okay? You can call this with an argument in your console. You have the server-side compilers, then we can call like C2, okay? We're gonna see on board in the next slide that we show this for us. And the C2 is usually enabled by adding the JVM startup option, okay? And this, like the calls, working on server side, looking in a server side. And we have an additional who calls tiered compilation. So it's really nice because this compilation adding the client side more the server side and makes the better of the two flavors of the JIT compiler. So in resume, combines client server and server side compilers. This way takes advantage in your JVM and is very nice. So you can see this image. I'm sorry if it's not good the quality, but you can check in this this link. So in this link they have the correctly managed. So if you are going to compare code that is purely interpreted or the use of a client-side compiler, you can see here that we have approximately 5 to 10 times the best performance in execution operation. So if you can hear this, we have an interpreter. So this is a code who doesn't use some compilers, and here you see you don't have performance executing. When you use the client and the server compilers, we have some performance. When you use all this, like this purple line, we have so much performance, like 30% to a 40% measurable, okay? So this can lead in the most case to performance improvements that can offset the additional cost of certain applications. So when you work in a big company, in a big system, in a big softwares, you need to choose compilers and something to adding performance in your application. So, okay. Let's see now more about the compilers too. Okay, this is a thing that I took in a website, Java World. So the Java World is writing for a guy who calls Bill Venners, and I reading something about bytecodes and compilers, and instead of that I reading, I look something like this. If you want to learn more about bytecode and JVM, see bytecode basics. So it's something that you need to know more. You need to know more how bytecode works, what is the deal, the bytecode, what is what is necessary bytecode inside your system, because we have a bytecode. So we need to understand this, and after this you understand how bytecoding works inside it in JVM. Okay, there are two types of compilation. We have the static compilation and we have the dynamic compilation. So in these slides, I'm going to show you the difference between them and when is necessary use them too, okay? So, okay. The static compilation is used in cases that we have static variables. So the returns of these variables will always be the best. The value that is placed. So an example that you can use of static compiler is with Java-C. So Java-C provides us a bytecode. So bytecode is something that is static because our variable is static too. And with the static compiler, the input code is interpreted once and the output is when the program is executed too, okay? So Java C is the more simple example that that you can see it without the static key compilation. And here is an example. So look at this example. In this code, we have an static variable, and this static variable returns a byte called static because the input is static too. So these things happens always when we put static variables. Is something that is common to happen in Java 5, I think. So I don't know more in Java 14 what happens because I don't remember. But when we put static variables, we have the returns in a byte code. Okay. So the other example of compilation is the dynamic compilation. So the dynamic compilation is a translation. What does it mean? Okay, example of dynamic compilation is the JIT, because JIT translates the byte code in something that our machine is gonna understand, a native code. Okay, machine code. I'm sorry. So here I put some topics. So the non-compilation translates for the another language automatically. The non-compilation gives for us runtime the advantage of being able to adapt to changes in application load. So really typical of JIT compilers. And most JVM use a dynamic compilation, so JIT is a proof of that. Okay, we have the hotspot too, but I don't talk about hotspot in this talk because we don't have so much time for this. So it's a tip for you guys to use before. Okay, and yes, most JVM use dynamic compilation like that we've seen before with the JIT compilers. So if you don't understand more about JIT, you can return these slides. I put the link of the slides before after my talk, so you can check this before. Okay, let's see more comparison about JVM versus JIT compiler. So most developers compare the JVM and JIT because thinks that the JVM and JIT work separately, but JVM and JIT works together, and we're gonna see this. So we're not gonna see a fight, okay? We're just gonna see a difference and comparison between them and how JVM and JIT works for our code makes better, okay? Okay, first we need to be very clear about the difference between the two. So JIT is a subset of JVM, which provides performance inside JVM. And JVM is used to execute byte code of Java developers, which makes the Java platform independent, whereas JIT compilers currently executing byte code into machine code language. So JIT is something like JavaScript is for TypeScript. I don't know how much JavaScript developers we have here, but you know that we have TypeScript. TypeScript is not another language. TypeScript is a subset of JavaScript. So it's not something better. It's something that works together to make our application better, okay? So don't have any fight, okay? The above is necessary to make our application faster and better, okay? So make this in our mind, okay? For me too. So, okay. Now we're gonna talk about memory management. It's the best part of JVM, in my opinion. I really like to talk about this. And okay, main things that we need to understand about memory within JVM is that JVM is divided in parts. So we have the heap memory, we have the no heap memory, and others that we're gonna talk. So the thing is, the parts of memory, a memory works like a machine. We don't, engineer, I'm sorry. We don't see the engineer works alone. Always the engineer works together to make something works, something vocal, something drive, okay? So this means that is all these parts necessary to compose all the objectives and methods and makes our code works. So the memory structure is something like this. We have the adding space. The adding space is allocated all the objectives when created. So it's something like just just created. So he stayed in the adding space. We have two survivor spaces like that I put S0 and S1. The survivor spaces is for objects that the garbage collector don't pass it yet. We have the old memory. Old memory stays the objectives without references and methods without a lot of referencing. So these methods and objectives is stayed on the old memory. Okay, it's something that our machine is don't use it for compiler code, and it's something that our garbage collector noticed that is not important for our application. For finally, we have a permanent generation, and permanent generation is stayed is the final compilation. Okay, going deeper and regarding the passage of the garbage collector, we have something like this. Okay, you notice that we have the young generation here. We have the young generation, we have the minor garbage collector, and we have the major garbage collector. Notice this XX because it's something switches memories that we're gonna talk yet, okay? So for finally, we have the permanent size. The permanent size is stayed on the permanent generation, and we have the young generation that is stay until ending space to the survivor spaces too. So let's see more about these space memories. The young generation stayed all the objects that they are created. So the most part of objects recently created stayed on the alien space. So before this, the object is collected by the garbage collector, and the garbage collector put this object in survivor spaces. So before this stayed in the survivor space. The survivor space, the name calls for us is like okay, you stated the garbage collector say to objection. Then okay, object stay this. I'm gonna pass here, okay. And when the major garbage collector pass here, you're gonna to all the space, okay. So pay attention, or you're gonna go to the permanent generation. So and when our objects stayed on the survivor spaces that have this this thing and then this mind, okay. So the old generation stayed all the objects that survivor of survivor spaces, but the object that the doesn't necessary for our application, okay. And we have the permanent generation. So isn't a part of Java heap memory. Permanent generation is populated by JVM at runtime based on the classes used by the application, okay? And with permanent generation, we have the Java SE library classes and methods. The objects in permanent generation are full collected for the garbage collector. So here the garbage collector turns all your deal, okay? So okay, we talk about the memory, but how we can use this in our application. Imagine that you have an application running, but it takes a long time to execute the final process. Many times it happens because we have a memory by default in our editor. And maybe the app that is developing asks for more memory or less memory. So it's something that not fits more in our application. So it's like something like this, the clothes that don't fit more, and we need to put more spaces in our memory or less spaces in our memory. So memory switches is for this, okay? So Java provides a lot of memory switches that you can use to set memory size and their hatches. Here, I have an example that you can use in IntelliJ IDEA. So IntelliJ IDEA is possible using go in a help menu. So and then edit custom VM options. And before this, you have something like this. This is spaces that comes by default in JVM. So you can edit this and you can measure. Oh my God, I don't know what the size of memories. I gonna put here on table like I'm table for, it is for you to check when you have some questions about this. And I have an article to explain how edit memory switch. Okay, I don't have so much time, but it's a real life to take deep in this. But if you need to know more, check on my blog, okay? I have an article explain how to do this in IntelliJ IDEA, the memory spaces that we have, how put this in your editor. You can I teach you in this with IntelliJ IDEA, but you can do this in Eclipse the same way, okay? Oh, check on my blog is anabenetti.com.br. I have a lot of articles too in the Dev2 website, so you can check there too, okay? So, okay, this is the table that I talk that I'm gonna show for you guys. Is really like to check this. And here we have a lot of VM switches that you can use and this description, okay? I'm gonna put the link of the slide so you can check this every time that we need, okay? So remember that at the beginning of the talk, I said that I was going to talk about something you want to monitor your JVM. This plugin is Java Mission Control. Java Mission Control or JVMC is a plugin that you can use it to set tools for diagnosing and profiling the Java virtual machine, okay? So it's very nice, and a plugin is a connector with JVM, and you can monitor your garbage collectors, and you can see more about JVMC in the side of Oracle, okay? I put the link here so you can check this link. The interface like this is very similar to Eclipse, precisely because it's a plugin inside it. So if you don't use Eclipse, you can see the same plugin in the IntelliJ IDEA. No, it's not the same. It's a plugin very similar who calls Java Flight Recorder. So I don't have so much time, but let's talk about Tunning's garbage collector. The main purpose of garbage collector is to take references and objects that are not going to be used and to emit memory within our application. So it's a big progress when you talk about application and developers that don't know what they do, okay? It's not everyone that know about something to improve application. So there are several types of garbage collector. So I'm gonna talk about here just two garbage collector, the serial garbage collector and J1 garbage collector. The serial garbage collector is the most simple implementation. It is designed for a single thread environments, and this garbage collector frees all application threads. You can use this argument to enable the serial garbage collector, okay? Just put it in your console and you can see. J1 is something robust, designing for run on multiprocessor machines, okay? And we have two spaces with J1 garbage collector, like marking and sweeping. And differencing of the serial garbage collector, the J1 separates the heap memory into regions and does the collection within them parallel. And you can enable with this argumenting tool, okay? So I'm gonna show you a quickly demo with the Softy, Wiki, and Python references to test your garbage collector. Okay, so Softy reference and Wiki reference is very similar, but in Softy reference, the garbage collector collects this kind of reference only when our application does not have enough of memory. Okay, so let's see this demo. I'm using the IntelliJ IDEA. So I think you can see this. So here, for starting, we have the soft references. So with soft references, we have some classings for tests. Here I use a simple startup Spring Boot applications who bring to me a lot of classes of tests, and I use in my POM.xml plugins to test my garbage collector too. So if I started this class, I'm gonna see how in what spaces my code is. So let's wait a little time. Okay, here you can see that our code is in heap space.
Sorry, Anna, but you are showing the presentation. I think you are missing the window from IntelliJ.
You don't see the IntelliJ IDEA?
No.
Oh my God. Okay, I think now it is. Okay.
Yeah, it's okay now. Sorry.
Okay. I'm sorry, guys. I think that I'm so sorry, but let me explain it again. Okay, here I have a lot of classes of tests, and I'm using a simple Spring Boot starting for this application. And in my POM.xml, I had a lot of plugins of garbage collector that I take in Maven repository. So I'm gonna test again the soft reference, and you can see that my code is gonna stop in a Java heap space. So, okay, here you can see that my code stops in Java heap space. So it's very nice. And here you can see that there are some methods to call the garbage collector. Okay, so let's see another references. So here, let's see the weak reference. The weak reference is more simple, and I use system.gc to call all the methods that the garbage collector is gonna take. If I run this class, I'm gonna see what space my code stops. Okay, this stops in Java heap space, and all my classes of tests passes through. So I put tests here and this test passage. Okay, put a string here, run the string here. And for finally, let me show you the soft reference. Let me correctly here. I test for the first the Python reference, and now we're gonna test soft reference. It's small too, and I'm using this annotation is a plugin of garbage collector too. And if I test here, you're gonna see where my test stopped, and if all my tests is gonna pass through. So, okay, Java heap space too. So here I can see all the methods that you can use with the plugin with garbage collector. Let me show you the POM.xml and the plugins. This code is in my GitHub, so you can show you there. So where? Okay, Workability is a plugin to test the garbage collector too. Let me share the presentation again. Okay. So, okay, we show the demo. Let's talk about the news of JVM in Java 14. We have the helpful no pointer exceptions. We have more memory allocation for the warm garbage collector, eventing streaming, so it's something like reactive program, and we have more spaces in macOS and Windows. The most
sorry, Anna. Sorry, I need to cut you off because we still have a few
it's fine.
questions.
I just finished. I finished. I finished. I'm
So
sorry.
thanks very much for your presentation. So I have a couple of questions from Theo Grip. So first one from him is, will Java code not execute in the JVM without the JIT?
The question is, Java code doesn't work without JVM with JIT? Is this the question?
Yes.
Okay, so JIT works with Java and JVM, but you can choose before you install the Java. So before you install the Java, you can choose JIT or hotspot, and how all of these two is necessary for in your application. Okay, we have the JIT by default, but you can choose in JIT, hotspot, have another ones, but I don't remember yet. Okay.
Okay, so he has another question, which is the memory structure the same independently of the garbage collector?
Yeah.
So independently of the garbage collector that you have, is the memory structure the same?
Okay, the memory structure always is the same, okay? The difference between the garbage collectors is the types of methods that this garbage collector is gonna take. But the simple memory structure that I showed for you guys is the same, okay? I show you the simple memory structure, and this memory structure always is the same.
Okay, so Eric Budal asks if does Itaú use other JVM languages other than Java?
If in Itaú use another language with JVM like Kotlin and Clojure and this stuff?
Yes.
Okay.
Or just Java?
Yes. We use it. We use Kotlin. We have some applications with Kotlin, and we have some. I think it's Kotlin. Java is we have more applications with Java, but we have some applications with Kotlin too.
Okay, so Patrick Del Bello, is asking if the project will be available on GitHub, the code that you saw. Okay. I don't know if you can. Okay, you have the link over there. So Patrick,
just check this QR code and you can download the presentation.
Okay, so Ana, thanks very much.
Thanks.
Very happy to have you here, and I hope next year you can come here to Coimbra and be live with us.
I really appreciate it.
Okay, thanks very much, and see you guys on the next session.
Hi, bye-bye. Thanks a lot.